Next, we're going to look at shading Venn diagrams. So we're going to look at the union, the intersect, we're going to look at the difference and the complement, and by the end of this, you'll be shading Venn diagrams like a pro. So before you get started, you're going to want two tools. You're going to make sure you have a good pencil, and you're going to want to have a very good eraser. So some of these techniques involve erasing. By the time you are experienced with it, you may be able to bypass that and just visualize what these look like, but until then, I would suggest that you probably want to actually shade and erase how I suggest. Okay, let's take a look at the first set relationship, and this is union. If we were dealing with logic, we would call this OR. So it's this symbol right here, so it looks a little bit like a U. So this is known as A union B, or you might hear it as A or B. So how do we shade A or B on a Venn diagram? So step one, we shade set A. So you can see that set A is completely shaded over here on the right. Step two, we're going to shade set B, and we're going to do it on the same diagram. So set A has already been shaded. Now we're going to shade set B, and we're finished. So this is A or B. So it's the everything that we shaded for A and everything that we shaded for B. You note that some of this stuff was shaded twice. Doesn't matter. When we're dealing with A or B, we just want to shade everything in set A and also shade everything in set B. So that is A or B. Okay, let's look at the next set relationship. Our next relationship is A intersect B. So it looks a little bit like this upside down U right here. It's also known as A and B. So if we were dealing with computer logic, we would call this AND. If we're dealing with set notation, we would call this intersect. You might hear me using both terms interchangeably. So how do I identify A and B? So step one, we're going to lightly shade A on the diagram. So lightly shade it. Step two, we're going to lightly shade B on the same diagram. So we have already shaded A. We're also going to shade B. So we've shaded them both on the same diagram. Now, I mentioned lightly shade. So we've shaded A, and we've shaded B on the same diagram. You should note that this part in between A and B, which is darkened on the diagram that I've created, was shaded twice. There's a part in set A that was only shaded once. There was a part in set B that was only shaded once. And then there was this part in the middle that was shaded twice. So if we want A intersect B, or A and B, we keep the stuff that was shaded twice, and we erase everything else. So I'm going to erase this part on the left that was only shaded once. I'm going to erase this part on the right that was only shaded once. But this stuff that was in the middle that was shaded twice, so it was shaded when I shaded in set A, and it was also shaded when I shaded in set B, I'm going to keep that. So what we end up with as a result is something that looks like this diagram on the bottom. So this is A and B, or A intersect B. So we shade set A lightly with a pencil. We shade set B lightly with a pencil. And then we look for the stuff that is shaded twice. We keep that. We erase everything else. So for the AND operation, we only keep what was shaded twice. All right, third operator is difference. So it's A followed by this backslash B. You might also see that referred to as minus. Sometimes you might also see it used with an actual subtraction symbol. So both of these notations I have seen. I would consider them both valid. The textbook for this particular course, and I would say most of what you might see in a university setting, my experience is it's used this backslash for a difference B, but I have seen the minus or the subtraction symbol up here. So if you see either one of those, it's referring to the same thing. Okay, so how does this work? So we have A difference B. So we're going to start by looking at set A and shading it. So we're going to shade set A. Now, next, we have B as the difference. So what we're going to do is we're going to look at set B, which I have circled in this diagram, and we're going to go over everything in set B with an eraser. Now, some of the stuff, the part that was in white, was already not shaded in, so going over with an eraser is not going to change anything in that case. But some had been shaded for set A, and that part has been erased. So we're left with this final result. So we have shaded in all of A, so this part was originally shaded, but then after it was erased, we're just left with the part that was highlighted on the left-hand side here. So for the minus or the difference operation, we shade the first set. So we would shade in everything that was in set A, and then we erase everything in set B. So first, we shade what's on the left, and then we erase what's on the right. It may turn out that not everything in this right-hand set was shaded, so not everything is necessarily going to get erased, but anything that we had shaded first is going to be erased. So that is A difference B. Okay, we have one left. Final one is the complement. And if we were dealing with logic or a computer, we would call this the not operator. So it's given by this prime symbol. I have seen a number of different notations for this outside of the mathematics setting and both inside the mathematics setting. So it is not uncommon to see this if you were in a computer science logic course. I have also seen this notation to mean the complement. We're going to use this one for this course, but realize that there are different symbols that might be used depending on what your setting is. Okay, so how do we find the complement of A? Well, the first thing that we do is we shade in set A. Now look at what I've shaded in. And maybe more specifically, look at what I have not shaded in. So this blue portion, notice that that is all of the stuff that was not shaded. So when we shaded in A, we did not shade in any of this other stuff. So I know I'm shading it right now, but that's the stuff that was not shaded when we shaded in set A. Well, notice that the complement, the logical word that is the equivalent of it, is not. And that is what we're looking for. We're looking for, if we had shaded set A, what is all of the stuff that is not shaded? And that is going to be our solution. So we want everything other than what they are asking us for. So if we see that complement symbol, it means think about what the original set would look like, and then shade everything else that was not shaded. So if you look at these two diagrams, this is set A, minus the x, of course, not including the x, and this would be the complement of A, or not A. So notice it is everything that was unshaded in the first diagram. Okay, we had 4 different notations. We have our first one was A or B. So if we have set A and set B, we shade both in. So we shade everything that was in set A, we shade everything that was in set B. Our second one A and B. So in this case, we're only interested in shading what would have been shaded if both of these were lightly shaded, and we want the stuff that's shaded twice. So if we had shaded A and shaded B, the part that I have identified here would have been the things that were shaded twice. We have A minus B, or A difference B. And what we would do to get A difference B is we would shade A, and then we would erase everything that's a part of set B, which would give us something that looks like this. Finally, we have this one, which is not A, otherwise known as the complement of A. So if we consider what set A would look like, set A would look like this, but we don't want that. We want the complement of that. So we're going to shade everything that was not inside of set A. So we would end up with this. Okay, in the next video I'm going to work through a few examples. So these were basic ideas of or, and, minus, and not. So let's see how this looks in practice.